Hello dear students, today in this video I am going to start your exercise 3.4. Before starting the chapter we have to know some concept here. So first of all, perfect number. Let's see what is perfect number. Perfect number. A perfect number is that, suppose n is a number and n has some factors. No? Every integer has factors, either 2 or more than 2 factors are there. Suppose n is a number and n has some factors. Within the those factors, n will be also a factor, no? Except n. If n is a number and all the factors of n except n, suppose 12 is a number, there are, what are the factors of 12? 1, 2, 3, 4, 6 and 12, no? These are the factors of 12. 1, 2, 3, 4, 6, 12, no? These are the factors of 12, no? So a perfect number is that, suppose if the sum of all these factors except this 12, which is the number itself, the sum of all this number or factor is equal to the number, then it is called a perfect number. Suppose as example, 6 is a perfect number. 6. Why 6 is a perfect number? What are the factor of 6? Factor of 6 are 1, 2, 3 and 6. These are the 4 factors of 6. So here except 6, the factors are 1, 2 and 3. Now if we add these 3 factors, we get 6, which is equal to the original number. That means when all the sum of all the factors except that number is equal to the number, then that number is called perfect number. Another example of perfect number is 28. What are the factors? If we see 1, 2, 4, 7, 14 and 28, no? Here 28 is the number which is also a factor. So except 28, if we add this number 1 plus 2 plus 4 plus 7 plus 14, if we add this number, what we get? Also 7 is there. 7. 1 plus 2 3, 3 plus 4 7, 7 plus 14 21, 21 plus 7 28, no? Which is the given number. So this is one perfect number. So I hope you understand what is perfect number. A perfect number is a number whose all factors except the number is equal to the sum of all factors except the number is equal to the given number. Then that number is called perfect number. So exercise 3.14, question number 1 is that express the following numbers as product of primes. There are many numbers. I have taken one such number, 1, 2, 3, 4. First number. So we have to show that, express it in the product of prime numbers, which you got in first chapter of your general mathematics. In that chapter also you have done this, very easy. We have to express this number as the product of prime numbers, no? So for that we have to find the prime factors of this number. So for that we have to divide the given numbers, no? 1, 2, 3, 4. So divide it. First of all, it will it is divisible by 2, as the unit place, in unit place there is 4, no? So divide 2 6 times, 1 time, 7 time. Next, 2 does not divide 6 on 7, no? So let's see what number divides 6 on 7. 6 on 7 and 7, 14. 3 does not divide, no? So if we check in this way, no other number divides 6 on 7. That means the 1, 2, therefore 1, 2, 3, 4 can be written as, since 6 on 7, no other number divides 6 on 7. So 6 on 7 is a prime and 2 is a prime. So 2 into 6 on 7, no? So this is the expression of the given number. So next is one more number, which is 10. Suppose it is one number, two number, 10140, 10140, two number 140. Let's check it in the same way. Solution 10140 divided 2 5 times. 2 does not divide 1, so 0. 2 divide 14 7 times, and 2 divide 4 7 times, and 0, no? Again 2 divide 5 2 times, carry 1 5 times, and 3 times, and 5 times. So now see 2 does not divide. 2 plus 7, 2 plus 5 7, 7 plus 3 10, 10 plus 5 15. So 3 divides 3 8 times, carry 1 13 13 4 times, and carry 1 5 times. So again divide by 9 12 12 and 5 17. So does not divide, so it is divisible by 5. So divide by 5 1 time, carry 3 34 6 times, 4 9 times, no? And then 13 times. That means there are so many prime factors of the given number. Therefore 10140 can be written as 2 into 3 into 5 into 13 into 13. So this is the solution. Very easy, these solutions are. So let's see question number 2. 2 number question is very easy. I am going to explain the 2 number question. 2 number question is that check whether the questions given or numbers given in question 1 are compound or prime. No? We have to check these numbers which we have solved, 1 2 3 4 1 0 1 4 0. This number are prime or composite. We have to check this, no? So very easy number. Since we have already done in one question number, all the you will do when you will solve all the questions of one number in this way. You will see that every number can be expressed as the product of some prime numbers. Suppose 1 2 3 4, it is expressed as 2 into 6 1 7. These two are factors of 1 2 3 4. Also 2 more factors are remained. That is 1 2 3 4 itself is a factor, and 1 is itself is a factor, no? For this number 2 2 3 5 13, no? That means 2 3 5 and 13. These are the factors of 10140, and 10140 itself a factor, and 1 is also a factor, no? That means we know when a number has more than 2 factors, then the number is called composite number. Since all these numbers have more than 2 factors, so we can say that the numbers are composite. So for that I am writing 1. Suppose 2 number 1 question will be like 2 3 4, no? So this is we can write it 1 2 3 4 as 2 into 6 1 7, no? So what we will, as we have done in question number 1, since 1 2 3 4 has more than 2 factors, therefore 1 2 3 4 is a composite number, no? Composite number. Very easy. Question number 3. Find 5 prime numbers which can be expressed as n square minus 2. So question may be quite different in your book, as I don't have a book with me, so I have written the question from Assamese medium book. Find 5 prime numbers which can be expressed as n square minus 2. That means we have to find such 5 prime numbers which can be expressed in this way, n square minus 2, where n should be a prime numbers, no? So we have to start with the first prime number. What is the first prime number? We have we have first prime number is 2, no? Let's see 2 can be expressed in this form or not. So when n is equal to 2, n nothing but prime number, no? So as we mentioned in the question, that find five prime numbers which can be expressed as n square minus 2. So we have to start with prime numbers, and our first prime number is n is equal to 2. When n is equal to 2, n square minus 2 will be what? N square minus 2 means 2 square minus 2. 2 square minus 2. That means what? Answer is 2. No? So this 2 is a prime number, and it can be expressed as in the form of n square minus 2, which we get 2 only, no? As we are getting the form in the, if we express a 2 in this form, then also we get 2. That means 2 can be expressed as n square minus 2. So it is a prime number of the form this, no? Next, prime number 3. Let's see. When n is equal to 3, then n square minus 2 will be what? 3 square minus 2. 3 square means 9. 9 minus 2, 7, no? So 7 is a prime number which can be expressed as in this form. Let's see. When n is equal to 4, no? Because 4 is composite number, n is equal to 5. So n square minus 2 is 5 square minus 2. That means 23. So 23 is also a prime number, no? Let's see. When n is equal to 7, n square minus 2, 7 square minus 2, which is 47. So 47 is also a prime number which is of the form n square minus 2. When n is equal to 9, no, don't, it is not 9. N is equal to 11, n square minus 2 is 11 square minus 2, 121 minus 2, that means 119. So it is also a prime number. So 5 prime numbers of the form, or which can be expressed as of the form n square minus 2 are 2, 7, 23, 47, 119. So these are the 5 prime numbers which can be expressed in this way. So let's see question number 5. Question number 5 is that for all integer n greater than 2, show that n to the power 4 plus 4 is a composite number. So we have to prove that this number n to the power 4 plus 2 is a composite number for n greater than 2, no? So for that, if we can express this number as the product of more than 2 factors, what is composite number? We know that composite number is a number whose factors are more than 2. That means if we can show that this number has more than 2 factors, then this number will be a composite number, no? So let's see how to solve this type of question. You will solve all this type of question in the same way which I am going to do. So n square plus 4, no? N square plus 4 can be written as n to the power 4 plus 4, no? N to the power 4 can be written as n square plus 2. 4 can be written as 2 square, no? This, there is no problem in this way, no? Now see, this is, we have one formula, a square plus b square. So it is matching with that formula, a square plus b square. It is nothing but a plus b whole square minus 2ab, no? 2ab. So here a means what? N square, and b means what? 2. So we can write n square plus 2 whole square minus 2 into a means n square, b means 2. No? Now see, n square plus 2 whole square minus here 4n square. No? Again n square plus 2 whole square minus 4n square can be written as twice n whole square. No? Again this is matching with the formula a square minus b square. See, n square plus 2 whole square, if we assume it as a square minus b square. So a square minus b square means what? A plus b, a minus b. So if we write, express in that way, n square plus 2 plus 2n and n square plus 2 minus 2n. Now see, this number, we have the number n to the power 4 plus 4, which can be written as the product of these two numbers. Now you observe that since we have value of n is greater than or equal to 2, no, that means n is positive number which is greater than 2. So if we put any number here, if we put 3 here, suppose 3, then 3 square 9 plus 2 11, 11 and 6 17, and here if we put the value of n square 3 9 plus 11 11 and minus 6, what, 5. So if we put the value of 3 here, we are getting 17 into 5, which both are what, prime numbers. No, that means since n is greater than or equal to 2, n is greater than or equal to 2, so these two things are always prime numbers for the value n greater than 2. So we can say that this number can be expressed as the product of what, prime numbers. No, so we can say that n to the power 4 plus 4 is a composite number. Or you can write in this also, n square plus 2n plus 2 into n square minus 2n plus 2. If we give a product 1, is it any problem? Is there any problem? No, because I have just multiplied one more number 1. Now see, this number has more than 3 factors. This is one factor, this is one factor, and this is one factor. No, so this, since this number has more than 2 factors, no, so this is what the given number is, a composite number. No? Or you can write in this way, since n is greater than equal to 2, therefore n square plus 2n plus 2 and n square minus 2n plus 2 are always prime. No? No? Always prime. These two are always prime. No? So n to the power 4 plus 4 expresses that, therefore n to the power 4 plus 4 is expressed as product of primes. Now, as we know, if we can express a number as the product of primes, that then the number is composite. Therefore n to the 4 is composite number. Or in short form, you can write, since n to the power 4 plus 4, or you can write this line simply, since n to the power 4 plus 4 has more than 2 factors, therefore it is a composite number. No, how more than 2 factors? Because 1 2 3, there are, we are showing 3 factors already here, because then more than 2 factors are there. If we put 3, then we will get 2 factors. If we put 4, then also we will get 2 factors. No, so there are so many factors for n to the power 4 plus 4. so we can write either this line or this line at the end. So thank you for today.